Hello wonderful person, this is Anton, and today we're going to go on a bit of a journey across the Milky Way galaxy, and specifically focus on some of the recent discoveries in regards to the recent history of our own home, and some of the more unusual discoveries when it comes to our own galaxy. And while as a species we've essentially only lived in the Milky Way galaxy, making this our true home, we're only now beginning to understand the true architecture and various types of activities in this massive structure, and how it potentially affects various planets, and thus possible life on those planets as well. And so in this video we're going to take a look at some of the major discoveries from the last few months, working our way backwards, starting with the most recent discovery from just a few days ago at the time of making of this video. And so here let's start with the discovery from April of 2026 on the so-called real edge of the galaxy, or in essence try to find out where does the galaxy actually end. And as always you can find all of the studies and all of the discoveries in the links in the description. But essentially for a very long time it was actually kind of difficult to tell where the galaxy seems to end, because obviously it does not really have a kind of a sharp border we expect from a more physical object. In essence, most galaxies just kind of fade away. However, by combining data from the ESA's Gaia spacecraft and some of the ground-based surveys like LAMOST and Apogee, astronomers discovered certain specific features that seem to suggest there is a kind of an end to the galaxy that can be physically defined by various types of stars that seem to be absent there. And so here astronomers found a kind of a U-shaped pattern in regards to the ages of stars. Okay, so what exactly does this mean? Well, normally, because of the process called inside-out growth, stars are younger the further you get from the galactic center. But at approximately 40,000 light-years away from the center, this trend suddenly reverses. Essentially, stars start to get older and older as you move from that point. And it looks like this particular reversal marks a kind of a true boundary of where the galaxy stops making new stars and where we can only find old stars afterwards. In other words, approximately 40,000 light-years away from the center, the star formation seems to stop. But I guess the question here is, so how did those old stars even get here? And well, the answer in this case is what's known as radial migration. So essentially think of stars like surfers trying to catch a wave. They can actually ride the gravity of the galaxy's spiral arms and with time move outwards from their initial birthplace. And this was one of the major discoveries in 2026 in regards to the origin of the solar system as well. Turns out it was actually formed much closer to the center and eventually made its way outwards, moving approximately 10,000 light-years away from the center. But this migration process is pretty slow and usually takes hundreds of millions or even billions of years. It's also more or less random. And because of this, the farthest stars are usually the ones that have been traveling the longest, essentially making them the oldest. But nevertheless, it's really at that distance of 40,000 light-years where researchers now believe star formation essentially stops completely. Now, it doesn't actually mean that stars cannot form past this region. As a matter of fact, as we'll discuss in a few minutes, they seem to form sometimes. But on average, the overall star formation seems to stop 40,000 light-years away from the center. And so here, by comparing some of the real-world data from various bright giant stars with the supercomputer simulations, the team confirmed that this age minimum seems to indicate the edge of the galactic star-forming region. In essence, definitively telling us where the edge of the galaxy seems to be. But the problem in this case is, of course, why? Why exactly does this edge exist? And what's causing this to be in this exact location? And though right now there are no exact explanations, there are possibly two reasons. First one could be the galactic bar, which causes the gas to move in a certain way and prevents star formation further out. But the second reason could be some kind of a galactic warp, which has been previously discovered, and we've discussed this in some of the previous videos. There's basically a kind of a slight bend in the overall shape of our own galaxy. It's not a true pancake, it seems to be slightly warped. Okay, so at least one more mystery to tackle in the future. Then we have some studies investigating how the galaxy evolved when it used to be much younger. And specifically here by using observations from the James Webb and by focusing on the galactic twins of the Milky Way galaxy, researchers were able to find out how similar galaxies seem to evolve. And so by looking at 900 individual galaxies at faraway distances, in this case resembling the Milky Way at different stages in life, the overall result from this recent study shows that galaxies seem to basically grow from inside out. In the beginning, they seem to be dominated by very dense, compact centers, but as they grow their outer regions, and specifically their disk, they eventually begin to gain mass and eventually become the primary factories for new stars. But one of the more intriguing discoveries in this case is that a lot of these younger galaxies seem to be extremely messy. And so basically they were not just pretty stable spirals we see today, but instead resembled very chaotic, very lumpy, and constantly colliding galaxies that seem to be super disorganized. Which actually tells us that our own galaxy, just as we suspected, very likely also had very violent and clumpy past, involving hundreds and hundreds of collisions. Which is why we actually see so many leftovers, such as various stellar streams and various globular clusters. Once again, a video in the description talks a little bit more about all of this. Then, sometimes last year, in 2025, we've also learned that the overall blueprint of how stars seem to form seems to be more or less the same, and even the same in some of the more lonely outskirts of the galaxy itself. And so here, by using the ALMA telescope, researchers observed and studied 5 individual star-forming regions in the outer galaxy, approximately 50,000 light-years away from the center. And here the primary discovery was the fact that researchers were able to discover individual protostellar outflows, or basically stellar jets, coming from these very distant baby stars. But in this case, they were forming in a very different low metallicity environment, involving somewhat primordial gas. Nevertheless, here, by studying these narrow jets moving at nearly 100 km per second, researchers were able to see what these stars are like and compare them to stars that are much closer to us. And so despite the fact that the chemistry here was quite different, the overall physics of the star birth was identical, with the star in this case expelling excess mass in various bursts every 900 to 4000 years in order to help itself grow. These types of episodic bursts are also observed in stars much closer to us. And so this suggests that there's a kind of a fundamental physical mechanism when it comes to star birth and star evolution. And it's very likely universal across not just our own galaxy, but the entire universe. And that's independent of the environment and the chemistry involved. But while physics is similar, the chemistry here was quite varied. For example, here researchers found a very low ratio of silicon monoxides and carbon monoxides, which is extremely unusual for stars of this type compared to what we see near us. And this suggests that the so-called shock chemistry, which basically produces various complex elements, including stuff we usually find in a lot of space dust, some of which eventually makes it to the surface of various planets, is very different for these low metallicity regions compared to our neighborhood in a galaxy. Then we have some studies on the so-called invisible skeleton. Here we're talking about the magnetic fields. And in this case, this is based on a lot of older studies and older observations from the now retired SOFIA telescope. But basically here, scientists were able to map these invisible structures pretty much across the entire Milky Way galaxy. But the focus for this recent study was the inner region referred to as Sagittarius C. And so here, by analyzing a lot of polarized light emitted by dust grains in this region, dust grains that usually align themselves with magnetic fields, the team behind this recent study was able to create detailed maps of this magnetic structure inside the zone, with the study revealing that there's a kind of a magnetic bubble, or basically the magnetic field is definitely not uniform, and instead seems to wrap around a very large expanding bubble formed by very hot electrified gas moving away from the center, with this bubble very likely being created and blown outwards by extremely powerful stellar winds from lots of different clusters of massive young stars in the center. And in this case, these observations also potentially solve one of the older radio mysteries in regards to the radio-emitting filaments you kind of see right here. This is also the central region, and you'll notice that there are a lot of these very strange filaments, thousands of which have been discovered in the galaxy over the years. And well, based on this recent study, one of the potential explanations suggests that these filaments are possibly created through magnetic reconnection, basically the snapping of field lines, which then accelerates particles to nearly the speed of light. In other words, just like our sun produces these snapping effects, which eventually result in massive explosions we refer to as coronal mass ejections, in this case, these magnetic reconnections seem to produce these extremely large filaments. And at the same time, researchers also discovered that at least some extremely massive stars, such as Wolf-Rayet stars with very powerful winds, seem to play a huge role in expanding this bubble and in shaping these magnetic fields. In other words, a lot of this effect is potentially caused by just a handful of extremely hot and very massive stars. But without these magnetic fields, which do act as a kind of a skeleton, the galaxy might have actually collapsed under its own gravity, or would at least look extremely differently. And so here the magnetic effects seem to play a large role in shaping the galaxy. As a matter of fact, at least in some regions, like inside the Sagittarius arm, the magnetic field actually seems to be reversed, going counterclockwise, whereas the rest of the galaxy goes clockwise. And this influences the motion of gas in this region, which then affects where and how the next generation of stars is going to be born. But naturally, these are just some of the preliminary observations, and we're still learning about all of this, even after decades of research and observations. And then, last but not least, we also have a discovery of a structure referred to as Pangu, which kind of made me laugh a little bit because even though in Chinese Pangu is actually some kind of a deity or some kind of a super powerful god, in Korean it just means farts. But that's beside the point. The point is that here, researchers believe they possibly found the oldest stellar disk in the Milky Way, now referred to as Pangu, which seems to have formed approximately 13.4 billion years ago, just 400 million years following the Big Bang. And in this case, this is a bit of a mystery, because according to modern theories, galaxies should not have been able to form organized structures like disks that quickly. As a matter of fact, this suggests that the original Milky Way started as a much smaller star-producing galaxy, even before it swallowed some of the first galaxies to become a little bit larger. But ironically, in just the last few months, additional observations from the James Webb Space Telescope discover disk-like galaxies very far away, suggesting that it's quite likely previous assumptions were just incorrect, and galaxies like the Milky Way potentially started growing much quicker, or basically started forming disk shapes within just a few 100 million years following the formation. And so here, by finding this Pangu, it essentially confirms that even the Milky Way started to grow much earlier. And yeah, making this part of the video was a little bit challenging because my kids were basically laughing every time I said Pangu, because they thought I'm talking about farts. But anyway, these are some of the major discoveries from the last few months, and essentially once again confirm that we still have so much to learn about our own galaxy, and there's still so much left to discover. From the fact that our galaxy very likely started growing very quickly in the first 400 million years following the Big Bang, to the fact that the magnetic fields seem to play a huge role in forming the galaxy and shaping what happens inside. But in this case, even that Pangu disk was only about 0.2% of Milky Way's current mass, implying that our galaxy was also extremely active in so-called galactic cannibalism. It basically acquired most of its mass by absorbing other galaxies. And so by discovering this, we're not just learning about how our galaxy was born, we're also discovering about the formation of other galaxies in the entire universe. And as we get more data from other surveys and other observations, we might finally be able to answer some of these more mysterious questions, such as how do you even define a galaxy, or how do you define its edge? But anyway, once we have some more answers, we'll discuss this more in some of the future videos. Until then, thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.